love Miss Food so much. She makes me feel like I'm in a safe learning environment.
All right.
This is how it should be.
So, Bruce, you had a question, you said?
What is on the last one?
No, the last problem?
Yeah.
Okay, what is number 45? Inverse. This is going to be, well, I already told you guys how important it is. Okay, so here they give you a graph. Here is the point 0, 1, and they have a graph that looks like this. In fact, that's tomorrow's lesson right there. So graph the inverse. Well, remember, how do you obtain the inverse?
You switch
You
X and
switch
Y.
the x's and y. So if this is 0, 1, then you need the point 1, 0, and then you know the graph is going to be symmetric about the line y equal x, right? So then the graph got to look like this then. It's got to be like a mirror image. See, like over here, or over here, the horizontal asymptote is y equals 0. So in the inverse, the vertical asymptote will be x equals 0, right? Because you switch the x's and y's. Anyway, if you have like super hard time, get more points like here. What does that look like? That looks like -1, comma. Okay, let's go with half. So then what's going to be on the inverse? 1/2 -1, then, right? So if you need more points, then just plug more points.
I don't know why I had such a hard time with it. Why I couldn't do it.
Because in geometry, didn't you guys do the thing with the mirror and then make make it symmetric?
Yeah.
Yeah, so you guys should be experts at this. Okay, I'm gonna just do a quick review of what we did last week because period 7, they forgot almost everything. Just believe me. Okay, so let's say you have a graph of a function, and it doesn't even have to be a function. Okay, let's say here is the point 0, 4. Here is the point -2, 0. So this is what the graph looks like. Yeah? So what if I ask you, because this is going to be on the next quiz, which is Thursday.
We don't have class tomorrow.
Yeah, we don't meet tomorrow. So how would you graph the inverse? You switch the x's and y's. So if you have 0, 4, it becomes 4, 0. And then what about this one? -2, 0 becomes 0, -2. And then it looks like this. And then how can you tell if you're right?
The middle of
It should be symmetric about the line y equal x. And it is.
So like, do we need like a straight edge or something?
No, I want you to graph everything freehand like this. Because the higher, once you hit pre-calculus, you're not using straight edges or anything like that. Everything is freehand. Because the graph is there to help you solve the problem. It is not the problem itself. Okay, now what else did we learn last week?
1-to-1. That was important.
Oh yeah. Okay, but if I give you, okay here, f of x is equal to 2x plus 3.
Oh, it's gonna equal 0.
F inverse of x is equal to, I'll just tell you what the answer is, x minus, I think this is the example I gave you last week. How do you show that they're inverses of each other? What did we do last week?
plug one in.
Yeah, very good. If you plug the inverse into the original function, or the original function into the inverse, you should always get the same answer, which is x. This is, and remember I boxed it last week? So, how would you show that these are actually inverses of each other? You plug one of them into the other. So if I were to take this and plug it in over there, what do you get? Well, no, you gotta actually show it though.
Okay.
So take this and plug it in, you get 2 times x plus 3. But what am I plugging in for x? X minus 3 plus 2, and then you go, hey, the 2's cancel out, the 3's cancel out, and what's left? And then you have to be able to do it the other way too. If you take this one and plug it into that one, you should also get x. So, if I take this and plug it in there, you get what? X minus 3 over 2. But what am I plugging in for x? That thing right there, 2x plus 3. And you can see that the 3's cancel out, the 2's cancel out, and all you're left with is x. So that's how you know they're inverses of each other. Okay, now on tonight's homework, we're just gonna algebraically come up with the inverse. So we're not, now I think some of the problems you're still gonna have to draw the graph, and they want you to draw the line y equal x in. And then to check your work, they're gonna want you to plug one into the other. So here, let's start off with an easy one. What if I give you a function, let's say 3x minus 5. Find the inverse. No, you know what? Yeah, okay, no. I changed my mind. I want 2x minus 1. Keep the number small. Now, how do you find the inverse? Well, when you graph the inverse of a graph, what do you do? You switch the x's and y's. So we're not going to do anything different here. So here's f of x. Think of that as y. You switch the x's and y's. So you get x equals 2y minus 1. That's how you get the inverse. You switch the x's and y's. But then you have to solve for y. So how do I solve for y in this equation? Isolate the y term. So bring the 1 on this side. Add 1 to both sides. And then you need to, how do I get rid of this 2? Divide both sides by 2, and there you go. This is f inverse of x. That's the inverse. So tonight's homework, that's how you find the inverse. It's so simple. You just switch the x's and the y's and then solve for y. But then again, they're going to want you to graph. So they want you to graph both of these, and they want you to show that it's symmetric about the line y equal x. So what's the fastest way of graphing this line? The y-intercept is -1, and if the slope is 2, that means if I go up 2, I gotta go right 1, yeah? So same thing, if I go up 2, I gotta go right 1. So it's kind of like that. Okay, what about this line? How do I graph this? Now, what you might want to do is, when you divide by 2, that's like dividing both of them by 2, so it's like 1/2 x plus 1/2, correct? You gotta know that now. When you take SAT and ACT, they love to put this on. A plus B over C is the same thing as A over C plus B over C. Coming up soon, that's why. Anyway, so what's the y-intercept of this line? 1/2. And if the slope is 1/2, that means if I go 1 down, I have to go 2 to the right or left?
What was the slope?
1/2. It's positive, so it's got to be going uphill.
Left.
So if I go 1 down, I got to go 2 left, or if I go 1 up, I got to go 2 left. So it looks like this. And then can you see that they're symmetric about the line y equal x? Yeah. And then they want you to actually show or verify that they're inverses of each other. So remember what I told you? We just did it over there. If you take this one and plug it into the original, you should get x. So let's see if that happens. So we're doing f of f inverse. That means you take the inverse and you plug it into the original function. What do you get? 2x minus 1. But what am I plugging in for the x here? That thing right there. 1/2 x plus 1/2. Distribute cut ties the 2. X plus 1 minus 1. The 1's cancel out and you get?
Wait, did
Yeah.
you have to do that though?
Well, if it says to in the book, if it says to verify it, then that's what you gotta do. That's how you verify their inverses. If you plug one into the other, the answer is x. Now, you gotta do the other one too. You gotta do the other direction. If you plug the original function into its inverse, the answer should also be x. So,
Do you have to do both? Okay. Was it yes or no
Did you
question?
hear that sigh?
yes. Well, everything in this class is optional, right? Everything in this class is optional.
Alright.
Do whatever you want. So you take this one and you plug it in for x there. So you get 1/2 x plus 1/2. Well, what am I plugging in for x? That thing right there. 2x minus 1. So what happens if I distribute that 1/2? You're going to get x minus 1/2 plus 1/2. But the halves cancel out and you get x. There you go. Whatever the book says, that's what you do. If they want you to graph it and show that it's symmetric about the line y equal x, you do that. If they want you to verify it algebraically, then that's what you do. You plug one into the other one, and the answer gotta come out right. So this is an example of a simple one because it's a line, but not all graphs are lines. So we're just gonna do one more example, and it's gonna be a tougher one. And then I'll just let you use the rest of the time for your homework. Okay, here we go. F of x is equal to, okay, let's make it kind of simple. 2x minus 1 all over x plus, give me a number.
3.
3 then, okay. Find the inverse. So this is like y, huh? So how do you find the inverse?
Switch the axes.
Switch the x's and y's. So x equals 2y minus 1 all over y plus 3. But this is why the other class had a difficult time. How do you solve for y? Because I see a y here and a y there. How do I solve for y? What do you do?
Multiply by the
Yeah. Okay, so in other words, cross multiply. Multiply both sides by y plus 3. So you're going to get x times y plus 3 is equal to 2y minus 1, right? Distributize the x, so xy plus 3x. Some of you can just do that part in your head already, right? Yeah, but Mr. Park, I got a y over here and a y over there. How do I solve for y? What do I do?
Move it to one side.
Exactly, move all the y's on one side of the equation. Where do you want to put it? Put all the y's on the left or right, it doesn't matter. Okay, let's bring in everything to the left. So anything with a y, bring it to the left. So subtract 2y. And then how do I get rid of this 3x here? You gotta subtract it on that side. So negative 3x minus 1. Now what? Factor out the y. This is algebra 1, people. And then, how do I get rid of this x minus 2? Divide by x minus 2. So you get negative 3x minus 1 all over x minus 2. There you go, that's the inverse. This is the inverse. And then how would you, what if they say show it algebraically that it's the inverse? Well, if I take that and plug it in here, and here now, I've got 2 x's there. What should you get as your answer? Or what if I took this one and plugged it in here and here? You should get x. I think you guys can do that. But what I want to do is we're going to draw the graph. Show that this graph and this graph are symmetric about the line y equal x. So, do we remember how to graph those things? We just did it last chapter, right? Rational functions. Okay, let's, remember the 4 steps I taught you? Have we forgotten everything already? Apparently.
No.
I'm pretty sure this problem's on the test, that's why. Okay, x-intercept. Look at the numerator. What makes the numerator 0? Okay, x-intercept 1/2. Y-intercept, plug in 0 for x. Negative 1/3. Vertical asymptote, that's when the denominator is 0. X equals negative 3, right there. Horizontal asymptote, if the degree of the top and the bottom are the same, which they are, then what do I look at? The coefficients, 2 over 1. So y equal 2 is the horizontal asymptote. And what does the graph look like? Is it going to be up here or is it going to be down there?
There.
Gotta be up here, how come?
Those points.
Because otherwise, if you drew it over here, it would cross the x-axis, but there's no x-intercept there, so it gotta be up there. And then since it's up there, how do I know it's exploding down over here? Because you got odd power, right, on the denominator. If one goes up, the other one goes down. And then I gotta cross through these 2 points, and then I gotta get closer to the horizontal asymptote. That's kind of an ugly graph. Let me make that nicer. Yeah. Whatever. Okay, now let's graph this one. Okay, go through the 4 steps again. X-intercept, what makes the top 0? 1/3 or negative 1/3? 1/3. 1/3 or negative 1/3?
Negative.
Thank you, it's negative 1/3. Oh my goodness, you gotta be kidding. Y-intercept, if I substitute 0 for x, what's negative 1 over negative 2?
1/2.
Thank you. vertical asymptote, what makes the denominator 0?
2.
X equal 2, so right here. Hope you guys can get these graphs straight. And then, what is the horizontal asymptote? Well, if the degree of the top and the bottom are the same, you look at the coefficients. So what would it be? What's negative 3 over 1? Negative 3! So y equal negative 3 is the horizontal asymptote. So are you keeping the point straight? I hope so. So, what were the two asymptotes? So this is it, and this is it. So, is the graph up here, or is it down there? It's gotta be up here, because you gotta pass through these 2 points you plotted. So it's like this. And then, since it's exploding up on this side, what?
Exploding down.
Yeah, it's gonna be down here. How come? Because you got it, power. If it goes up on one side, it goes down on the other side. And then, are these two graphs symmetric about the line y equal x? Yeah, well, that's a work of art right there. Thank you. It's pretty nice, man. Pretty nice, if I do say so myself. So everybody can do it with lines, right? Because lines are simple, but then you gotta be able to, that's why we learned last chapter, so you can graph things like this. Anyway, we have a quiz on Thursday, and by popular demand, the other class asked if there could be a practice quiz. Okay, I'll post it up on the site by Wednesday. Okay, any questions on this? So tonight's homework is really easy. Switch to x's and y's, and then solve for y. That's how you find the integral. But see, we're going to be doing this over and over and over. You're going to, like, when we, how many of you are taking trigonometry? Okay, we're going to do it in trigonometry. We still got to learn some more graphs. We haven't learned all the graphs. We're going to be doing those. That's because this concept of inverse is very important in calculus. In fact, everything is important in calculus, as you will find out as you get there. Okay, we're done then. How come you guys only get 35 minutes? The other class was 40 minutes.
I didn't even talk. I didn't ask any questions.
Okay, well, I don't know. Okay, I'll give you the rest of the time to finish your homework. Yeah, here's an idea. What if I do all my homework now, then I don't even have to worry about it? That's not gonna happen. Whatever.